Hello everybody, welcome into another lesson. So today we are going to do the surface area of pyramids, cones, and spheres. So for pyramids we're going to stick strictly with square pyramids, probably because they're the easiest to work with. So a pyramid, of course, as we know, has one base, and then it's got one base that's a perfect square for a square pyramid, but it's got four faces that are triangles because each side meets at a certain point above the base of the pyramid. So when you do that, each of the faces becomes a triangle. You're going to know how many faces you have in a pyramid by the number of sides your base has. So if this were a triangular pyramid, you would have only three faces. You would have three triangular faces instead of four. If it was a pentagonal pyramid, you would have five triangular faces and then the base being a pentagon because the base has five sides then. But this is a square pyramid. You have a base that's a square plus four faces that are triangles. So the surface area of a pyramid is the lateral area plus the area of the base. Well, the lateral area is different when it comes to pyramids and cones than it is with prisms and cylinders. When you take the lateral area of a pyramid, it's going to be the number of sides, the number of faces rather. It's the number of faces you have times the area of one of those faces. So the number of faces you have times the area of one of those faces. That's the lateral area. So for a square pyramid, we have four faces, so that's how we get 4 times half the base times this L, which is the slant height. The slant height of a pyramid is not the height of the pyramid itself, it's the height of each triangular face. It's the height of the triangle per se, the height of each triangular face. That's the slant height. So your lateral area is going to be the number of faces, which is 4 in a square pyramid, times the area of that of each triangle, which would be half the base times the slant height, or 1/2 BL, plus that area of the base for the surface area. When you add these together, you get the surface area. The area of a square which is the area of the base, is a side squared. Well, it works out that when we take 4 times half the base times the slant height rather, you get 2 times the base times the slant height for your lateral area. Now, the base of the triangle is also a side of the base of the square. It works out where they're both the same. That's how we have B and S both for the base of the triangle and a side length of the base of the square. So your total surface area is twice the base times the slant height plus the base squared. That's how we came up with that. So once again, the surface area of a pyramid equals the lateral area plus the area of the base. The lateral area is however many faces you have. You'll know how many faces you're going to have by how many sides your base has. In this case, it's a square, so we have 4 faces, because a square has 4 sides. Now your faces in a pyramid are always a triangle. It'll always be a triangle in a pyramid. So in this case, we take 4, which is the number of faces, times the area of one of these triangles, which would be half the length of the base times the slant height. That's your lateral area. Then plus you take the area of the base, which is a side of the square squared. Well, when we do 4 times half the base times the slant height, we get twice the base times the slant height, plus we can use the fact that the base of the triangle is also the length of the side of the square base. So we could do twice the base times the slant height plus the base squared. That's how you'll get the surface area formula for a square pyramid. So let's dive into some examples here, okay? Let's say we have the base being 10 centimeters. The base is 10 centimeters, which is also that's the base of the triangle, and the length of the side of the square base is 10 centimeters. Your slant height would be 15 centimeters. So we have the length of the base of the triangle and the length of the side of the square base being 10 centimeters. We have the slant height of the square faces being 15, the slant height of the triangular faces being 15 centimeters. So to find the surface area, what we're going to want to do is take 2 times the length of the base, which is 10 centimeters, times that slant height of 15 centimeters, plus we take the base squared, which is also the length of the side of the square. We'll take that 10 centimeters to the second power. So now for the first term, you'll just do the multiplication. 2 times 10 is 20, times 15, that's 300. Centimeters times centimeters, that would be square centimeters. Plus then you have, for the second term, you have 10 to the second power, that's 100. Centimeters to the second power, that's square centimeters. Now you just got to add these two terms together. 300 plus 100, that is 400. Then centimeters squared. So the surface area of this square pyramid is going to be 400 square centimeters. That's what you would get, 400 square centimeters. And I'll do 2 more examples. So for your formula for a square pyramid, again, remember, if you remember nothing else, it's the lateral area plus the base. Your lateral area is going to be the number of faces you have times the area of a triangle, which that L, you could say H, you could name the H the slant height, but in most textbooks L is usually the slant height. But you could have said H also for the slant height. But the slant height, again, is not the height of the pyramid itself, it's the height of the triangular face. It's like the height of a triangle. That's all it is. So your lateral area is going to be the number of faces times the area of a triangle plus the base, which is going to be a side of your square base squared. And as it turns out, the base of the triangle is also the length of the side of your square base. They're the same thing. So that's how we get the final result here. So that's how you can derive the formula for a square pyramid. And if you had a triangular pyramid, then it would look a little bit different. You would derive the formula for a triangular pyramid, but the overall formula is the lateral area plus the area of the base. That's true for pyramids or for cones, which we'll get into cones in a minute. But let's say we have the length of the base of the triangle, which is also the length of the side of the square, being 5 inches. We have the height being 11 inches. We want to find the surface area. So the surface area of this particular pyramid is going to be twice or 2 times the length of your base, which would be 5 inches, times your slant height of 11 inches, plus the base of the triangle squared, or the side of the square squared. Well, first term we do the multiplication. 2 times 5 is 10 times 11, that's 110. Inches times inches, that is inches squared. Plus you have 5 to the second power, well that's 25. Inches to the second power, that's square inches. Now you just add 110 and 25 together, you'll get 135 square inches. So the area of this square pyramid is going to be 135 square inches. Alright, I will do one more example here with a pyramid, then we're going to move on to a cone. Alright, what do we got here? Length of the base would be 20 feet. The slant height's going to be, we'll say 30 feet. Slant height is 30 feet. So we'll find the surface area of this square pyramid. That'll be equal to 2 times the length of the base, being 20 feet, times your slant height of 30 feet, plus your base of the square, which is also the length, the base of the triangle, or the length of the side of the square to the second power, which would be 20 feet to the second power. So for the first term, let's do the multiplication. 2 times 20 is 40. 40 times 30, that's 1,200 or 1,200. Feet times feet, that's square feet. Plus you have 20 feet to the second power. Well, 20 squared, that's 400. Feet squared is just that, it's square feet. Now you go ahead and add 1,200 plus 400, you will get 1,600 square feet for your pyramid. That'll be your surface area of this particular square pyramid, would be 1,600 square feet. So, one more time with this, the surface area of your pyramid is the lateral area plus the area of the base. Your lateral area is always the number of faces you have. You'll know how many faces you're going to have by counting the number of sides the base has. The base, being a square, has 4 sides, so that's how many faces you're going to have. Now each face in any pyramid is always a triangle. So you'll take the number of faces times the area of a triangle, which that L is the slant height, not the height of the pyramid, but it's the height of each triangular face. The height of that triangle, which would be whatever your length is for that. So it's going to be the number of faces times the area of a triangle plus the area of the square base, which would be a side length of the square to the second power. So when I do the multiplication of 4 times the area of the triangle, I'll get 2 times the length of the base times the slant height, plus I can use the fact that the length of the base of the triangle is also the length of the side of the square. It's the same thing. So that's how I interchange B and S. I just figured it'd be easier to have the same letters instead of different letters to represent the same thing. If you're trying to represent the same number, it's best that you pick the same variable then, because if you have another variable, it can get confusing very quickly. So that's how we got the formula for a square pyramid. So if you remember nothing else, lateral area plus the area of the base. Alright, let's move on to cones. We will move on to cones now. Cones are similar to pyramids in the fact that there's only one base, but the difference is that the base is a circle. So let's draw our handy dandy cone. Draw our nice cone. I apologize, I'm not exactly Bob Ross, but that's a nice big cone. Okay. So we got a nice big cone here. We have the radius of the circle base, and then each of these edges here where it kind of stands up to meet to a point above the base of the circle, that is your slant height, L. That is going to be your slant height, L. So again, the surface area of a cone is the lateral area plus the area of the base. But it's a little bit different with the cone for the lateral area. The lateral area, of course, is anything but the area of the base. That's always been true no matter what shape you have. The lateral area, you kind of just got to remember this. The lateral area of a cone is pi times the radius times the slant height. So that lateral area is pi r times L. Now what's the area of the base? What's the area of a circle, in other words? That'd be pi r squared. So the surface area of a cone ends up being pi times the radius times the slant height plus pi r squared. So let's do 3 examples here of a cone. Let's say we have a radius of 7 yards. We have a slant height of 20 yards. So the radius of the base is 7 yards. The slant height of the cone is 20 yards. To get the surface area, I'm going to take pi times my radius of 7 yards times my slant height of 20 yards plus I'm going to take pi times that radius of 7 yards to the second power. Well, let's go ahead and do our first term here. Let's ignore pi for a minute. Let's leave pi on the outside. But let's do our multiplication. 7 times 20, that's 140. Which I suppose would be 140 pi. Until you're ready at the end, I would treat pi almost like a variable. You'll have 140 pi, then yards times yards, that's square yards. Plus you'll have pi times, then you have 7 to the second power, that's 49. So you'd have 49 times pi, yards to the second power is just that, that'd be square yards. So now we can go ahead and add these up, simplify them. 140 pi plus 49 pi, that's 189 pi. You'll have 189 pi square yards. Now we want to make this make sense. We want to take 189 times pi, we want to round that to 2 decimal places. So let's go ahead and do just that here. 189 times pi is 593.76. Alright, come on. Here we go. So the surface area of this particular cone is going to be 593.76 square yards. And we'll do 2 more examples here. Alright, let's see. Let's take the radius, we'll make that 12 kilometers. We'll make the slant height 22 kilometers. So I got a radius of the circle being 12 kilometers. I have the slant height being 22 kilometers. I want to find the surface area. So again, the surface area of a cone ends up being pi times the length of your radius, which is 12 kilometers, times your slant height, which is 22 kilometers, plus the pi times your radius of 12 kilometers to the 2nd power. So let's go ahead and do the multiplication for the first term. I gotta take 22 times 12. I'm going to treat pi like a variable for just a minute. So 22 times 12 is 264. I would get 264 pi. Then kilometers times kilometers, that's square kilometers, plus I gotta do pi times 12 to the 2nd power, that'd be 144. Solve 144 times pi. Kilometers to the 2nd power is, well, square kilometers. So now all you have to do is add 264 pi plus 144 pi. Let me go ahead and add those 2 numbers. 264 plus 144. That's going to be 408 pi kilometers squared. So now we want to make this make sense. We got to do 408 times pi. We will get the surface area rounded to 2 decimal places. So 408 pi is 1,281.77. 1,281.77 square kilometers. So the surface area of this particular cone comes out to be about 1,281.77 square kilometers. Now I'll do one more example. So again, surface area of your cone is just going to be nothing more than the lateral area plus the area of the base. The lateral area is pi times the length of the radius times the slant height. Then you got to add the area of your base to get your surface area. The area of the base is the area of the circle, which is pi r squared. So the surface area formula for a cone is pi RL plus pi r squared. So let's go ahead, let's see here. We'll do 17 inches for the length of this radius. We'll do 30 inches for the slant height. So the slant height will be 30 inches. Again, I cannot emphasize this enough. Slant height is not the height of the cone. Slant height is where you see the kind of the sides of the cone. Basically, that's your slant height. So the surface area is going to be equal to pi times that radius of 17 inches times that slant height of 30 inches plus pi times that radius of 17 inches to the second power. Okay. So let's do the first term. We'll treat pi like a variable. We'll do 17 times 30. That'd be 510 pi. Inches times inches, that's square inches. Plus, I want to say, all right, 17 to the second. I believe that's 289, but don't quote me. It is 289. Okay. So you'll have plus 289 pi. Inches to the second power is just that. It's square inches. So now you're going to go ahead and add these up. You're going to do 510 pi plus 289 pi. That would be 799 pi. Then inches squared, or square inches, however you'd like to say it. Now we're going to make this make sense. To get our surface area, we're going to take 799 times pi and round it to 2 decimal places. So 799 pi, that's 2,510.13. So that comes out to be about 2,510.13 square inches. So the surface area of this cone is about 2,510.13 square inches. And that's it for cones. We're going to move on to our final one today, which will be spheres. We are going to do spheres, which are actually surprisingly easy. Spheres are not bad at all. Alright. Sphere. Let's see. Alright, we got a sphere. I will draw the radius of the sphere. Let's draw the radius of the sphere. So we got a nice ball, a nice sphere. The surface area of a sphere is surprisingly easy. It's just equal to 4 pi r squared. That is the surface area of a sphere, is 4 pi r squared. There's really no easier way to remember it. It's just 4 times the area of a circle, 4 pi r squared. That therefore would be the surface area of a sphere. So let's do 3 examples with a sphere. Let's say this sphere has a radius of 50 miles. The radius is 50 miles for this sphere. So to find the surface area, we're going to take 4 times pi times that radius of 50 miles to the second power. Alright, well, order of operations dictates we do the exponents first, so we'll still have 4 times pi, but 50 to the second power, that's going to be 2,500, or 2,500. Miles squared, well, that's just square miles. Now let's go ahead and simplify this. We'll treat pi like a variable. 4 times 2,500, that's 10,000. So you'd have 10,000 pi miles squared. So now we're going to make this make sense. We're going to take 10,000 times pi and round the result to the nearest 2 decimal places. So 10,000 times pi is 31,415.93. 31,415.93 square miles. So the surface area of the sphere is about 31,415.93 square miles. That's exactly what you get for the surface area of the sphere. And I will do 2 more examples still. Let's say the radius of this sphere is 15 feet. Alright, so the radius of this sphere is 15 feet. We want to find the surface area of the sphere, so we're going to take 4 pi times that radius of 15 feet to the second power. Well, order of operations dictates, again, we got to do the exponents first, so we'll do 4 pi. Now 15 to the second power, that's 225. Then feet to the second power, well, that's square feet. So we have 4 pi times 225 square feet. Let's go ahead, let's simplify this further. We'll treat pi like a variable. Let's do 225 times 4. That would end up being 900 pi feet squared. 900 pi square feet. Now let's go ahead and let's round the result to about 2 decimal places. We'll have our surface area. You would get about 2,827.43. 2,827.43 square feet for the surface area of the sphere. It would be about 2,827.43 square feet. And yes, I will do one more example. Alright, well, we can't have the same radius. That would be kind of stupid if I'm going to do another example. Let's say the radius of this sphere is going to be, it's a small one. I'll say 3 centimeters. The radius of this sphere is about 3 centimeters. So I want to find the surface area of this sphere. Again, I'm going to take 4 times pi times that radius of 3 centimeters to the second power. Well, order of operations dictates we do the exponents first. We'll have 4 times pi, then 3 to the second power is 9, centimeters to the second power, that becomes square centimeters. So now we'll simplify this. We'll treat pi like a variable. 4 times 9, that's 36. So you'd have 36 pi square centimeters. Now let's simplify this here by doing the multiplication. And we will round the result to 2 decimal places in true fashion. So 36 pi is 113.1. that come out to about 113.1 square centimeters. So yes, the surface area of the sphere is about 113.1 square centimeters. So folks, this has been it for pre-algebra. We are done with pre-algebra as of today. This was the final lesson. So next we will be getting into Algebra 1. So stay tuned for the Algebra 1 welcome video. Thank you everybody who has followed the channel so far. Thank you for those who have been there since day one. I really appreciate you. Thank you for those who have followed recently. Thank you to those who will follow, I should say subscribe, it's YouTube. Thank you to those who will subscribe in the future. And if you're enjoying the content or you find this helpful in any way, please consider subscribing to the channel. It's free of charge. It'll cost you absolutely nothing. It just helps my channel grow, helps me push the content out there. All my videos will be there forever from all the playlists. I have the Basic Math 1 playlist, Basic Math 2, and now Pre-Algebra, which just finished up today. And then about to be the Algebra 1 playlist also. We'll have that. So I thank you everybody again, and I will see you soon. Take care.